I'm going to start by introducing you to some new terms and ways of talking about sequences. So the first one I'm going to talk about is the recurrence relation, which looks like this. Now D here stands for the common difference. So if we look at this example below, what we can see is that the common difference here is 3. So our D equals 3. So what this recurrence relation is telling us is it's telling us how to find the next term in the sequence. So the last term that we've got in this sequence at the moment is 20. To get the next term in the sequence, you do 20 plus 3, and that would give you 23. That would be the next one in the sequence. We'd write down formally our sequence as a k plus 1 equals a k plus 3. So if you were asked to find the 21st term, and you've been told that A20, which is the 20th term, was 52. Then to get A21, the 21st term, you're going to take A20 and add 3 to it, which in this case would be 52 plus 3, which would be 55. So we're used to being able to find the nth term, and we've got a system for doing that, but here we're going to introduce you to another way of writing it and working it out. So nth term and un, with the n down at the bottom there, mean the same thing. And we've got this little formula here. So a is going to be the first term in the sequence. D we've already come across, that's the common difference. And N is the term that you want. So let's have a look at this in practice. So I've written a sequence down, but I've written it down vertically instead of horizontally for a change. But what we can see from this sequence is that A equals 3 and D equals 4. Okay, now what I'm going to attempt to do here is just show how this formula sort of works. So 3 is the first term, and if we wanted U1, it would be 3 plus n, which in this case is 1 minus 1, so that's 0, times the difference, which is 4. And so 3 plus nothing times 4 is 3 plus nothing, so that's where we get the 3 from. So our U2 would be 3 again, plus, now this time it's going to be 2 minus 1, so that's going to be 1 times 4. And so 3 plus 4 makes 7. U3 is 3 plus 2 lots of 4, because n is 3, n minus 1 is 2. So that gives us our 11. U4, hopefully you're seeing how this formula works now, is going to give us our 15, and I'll just finish off. So here's a little example of a question. We're being asked to find the 15th term of a sequence given that the first term is minus 5 and the common difference is 7. So what do we know? We know that n is 15, A is minus 5, and D is 7. So we're just going to put all that in. So we're trying to find the 15th term, which is U15, and that's going to be minus 5 plus 14, remember we've got to take one off, times 7. If we work all of that out, we'll get 93. So another new term is the word series, and a series is what you get when you add together the terms in a sequence. So when they want you to do that, they want you to add or sum together, find the total sum of all the terms in the sequence, then SN here is one of the common notations. There is another one, we'll cover that a little bit later. So what you can see that there are two formulas here that we can use to work that out. So let's just talk about the letters in there. So N is the number of terms, A is the first term, L is a new one for us. L stands for last term. And then of course we've got our D, which stands for our common difference. So to work out the sum of the series, you're going to add the first term to the last term and multiply it by half of the number of terms that's in there. Okay. Now what I'm going to show you next is how we get this second formula from the first one. So the difference between the two is that in the first one we're using L, the last term. Now sometimes you might not know the last term, and so this second one is useful in that circumstance. But the trick to understanding how this second one comes from the first one is to write down another way of saying the last term. So the last term would be the same as UN, because that would be the last term in the series. And that we know we can write down as A plus N minus 1 D. So if we substitute that in instead of the L, we can see that we've got N over 2, A plus N minus 1 D, and tidying that up, that gives us our 2A plus N minus 1 D. So now we're going to use that formula. So what have we been told here? We want to find the sum of the series that starts with 8. So that means A equals 8. Ends with 9.5. So L equals 9.5. And we're told that it has 7 terms. So N equals 7. So our little formula is Sn equals N over 2 A plus L. So that's 7 over 2, 8 plus 9.5. And so if we work all of that out, we get 61.25. So let's do another one. So this series starts with 21. So we know that A equals 21. We know that the sixth term is 11. So U6 equals 11. We need to find the common difference and then find the sum of the first 100 terms. So the first job for us is to find the common difference. So we're going to use our formula UN equals A plus N minus 1 D. So in our case it's U6 equals A plus N is 6, so N minus 1 is 5, so that's 5D. And we know that that equals 11. So we've got 21 plus 5D equals 11. So 5D equals 11 minus 21, which equals minus 10, and so D equals minus 2. Now we know what D is, we can do the second part and find the sum, so S of the first 100. So it's n over 2, so that's 100 over 2. Now we're going to need to use the second one because we don't know the last term. So it's going to be 2 times the first term, which is 21, plus n minus 1, so that's 99 in this case, times our common difference, which we worked out as being minus 2. So if we tidy that up a bit, we've got 50 times 42, and then we've got minus 198 there. And taking that further and working all of that out, we get minus 7,800. So here's another question that is actually asking for the same thing, but you can see it's written in a very different way. So this epsilon sign, that's what this is here, means sum of. So what's written here is same as finding S15. So the first thing we need to do is find the first and the last term, because we know those are useful to us. So the first term will be when n equals 1, and when n equals 1, 2n will be 2 plus 3, so that will make 5. And we also need the last term, which will be when n equals 15. So that will be 2 times 15, which is 30, plus 3 equals 33. So 5 is our A, 33 is our L, and our N is 15. So to find the sum of the first 15 terms, it's going to be N, which is 15 over 2. And then we've got 5 plus 33, A plus L. So that's 7.5 times by 38, and working that out we get 285.